Well, in this video we're looking at the structure of the nephrons in the kidney and relating the position of the nephrons to the overall structure of the kidney itself. Now, what we're looking at here, this is the renal cortex, the outer layer, and below we have the renal medulla, the lower layer. So what we notice is that the structures here that we see in the cortex. Now the nephron is the whole structural unit of the kidney, and it's in two parts. At the top here we have the renal corpuscles. So these are the renal corpuscles, and then going through the cortex down into the medulla we have the renal tubules. So a nephron consists of the corpuscle and the renal tubule. They're the two parts of the functional unit of the kidney, which is the nephron. Now, there's probably round about 1 million nephrons in your kidney at the moment. That is, in each kidney. Studies have shown that there's between about 250,000 and 1.1 million typically nephrons in a kidney. And the number of nephrons is developmentally determined because at 36 weeks gestation there is the maximum number of nephrons you're ever going to possess. And these can be lost with age as well as through disease processes. So we see the nephron is the renal corpuscle and the renal tubule. Now within the renal corpuscle there's actually two components. If we focus in on a single renal corpuscle there, we can see that there's actually two parts to this. The inner part here, this is the glomerulus. That is the ball of capillaries, the glomerulus. And the outer part, round about, is known as Bowman's capsule. So two parts to the renal corpuscle, the glomerulus and the Bowman's capsule. And there's also different components to the renal tubules. Firstly, we have the first convoluted tubule. So this bit here is the first or the proximal convoluted tubule. Then we go on down to the loop of the nephron, dipping down into the medulla, then going back up again. And then we notice there is a distal or a second convoluted tubule here. And these convoluted tubules pass material into the collecting duct. And here we see a collecting duct going down through the kidney. It becomes larger as it goes down because it collects more nephrons draining into it until we get to the bottom, and this bottom part here is where the urine comes out, and that bit's called the papillary duct. Now, there are basically two types of nephron. There are cortical nephrons and there are juxtamedullary nephrons. Now, the cortical nephrons are in the outer part of the cortex. So in this model, that is the top part of the cortex. And this is the outer part of the cortex along here. And these tend to have relatively short loops. So if we trace this cortical nephron here, we see that the corpuscle is in the outer part of the cortex. The same would be true of this one or this one. And then we notice that there's a relatively short loop before it goes back up and drains into the collecting duct here. And 80 to 85% of nephrons are these cortical type of nephrons. The other type of nephron, the other 15% or so, 15 to 20%, are the juxtamedullary nephrons. Now the medulla of the kidney is this part here. This is the medulla, the inside part, and juxta means beside. So the juxtamedullary nephrons have their corpuscles near the medulla. And here we can see a corpuscle which is near the medulla. So this is a juxtamedullary nephron. And these have long loops of Henle. Long loops going down. So if we trace the course of this particular nephron, we have the proximal convoluted tubule going down. We have a thick and a thin loop. So we have a descending loop, we have an ascending loop, descending down, ascending, going back up. And then we notice the distal convoluted tubule here, before this also drains back into the collecting duct. So that's a juxtamedullary nephron. And they have an ascending thin tubule as well as a thicker tubule. Actually, the lumen inside is the same thickness, it's just the thickness of the wall that varies. Now the nephrons in the kidney, as we've said, are the functional unit of the kidney, and they have three main functions. The first function is glomerular filtration, and the glomerular filtration takes place in the renal corpuscles. And this is the first step in urine production. And glomerular filtrate is produced from the blood. It filters into the Bowman's capsule and on into the nephron. The process of ultrafiltration forming glomerular filtrate. And very large volumes of glomerular filtrate are formed every day as the blood is filtered. So for the typical woman watching this video, maybe about 150 litres of glomerular filtrate a day are formed. And if you think that your blood volume is probably 5 litres, you start to get an impression of just how active a physiological process this is. In men it may be more, maybe 180 litres a day of glomerular filtrate are formed. And that passes into these tubules, into the first convoluted tubule, through the loop up into the second convoluted tubule. And if you think about it, 180 litres, that's actually 7.5 litres per hour. And that works out at about 125 mils of filtrate being formed per minute between the two kidneys. So about 1 million nephrons in each kidney. Collectively, the two kidneys producing about 125 mils of glomerular filtrate per minute. And most of this is going to be reabsorbed. So once the filtrate has gone into the tubule, most of it will be reabsorbed back into the blood, maybe 99% of it, because whatever is not reabsorbed will end up at the bottom of the collecting duct, at the papillary duct there, and that is urine. So by the time it gets down to here, it's actually urine. And you're probably going to produce 1,500 to 2 litres of urine per day, depending on how much you drink. So if you're producing 180 mils of glomerular filtrate, you can see that maybe 178 litres of that is going to be reabsorbed if you're producing 2 litres of urine per day. And then in the tubules, there's two main functions. And the first is tubular reabsorption. Now, in the nephron, between the glomerulus and the Bowman's capsule, there's going to be ultrafiltration on grounds of molecular size. So this means that glucose is going to be filtered out. amino acids are going to be filtered out, and you want to reabsorb these back into the blood, because we don't want amino acids and we don't want glucose to be lost in the urine. They're essential food products. So it would be abnormal for urine to contain glucose or amino acids. And we want water to be absorbed in just the right amount. And we also want the electrolytes, the sodium, the potassium, the calcium, again to be reabsorbed in just the right amounts. And another process that goes on from the tubules is we have reabsorption from the tubule to the blood, but then from the blood to the tubule we have another process called tubular secretion. So, for example, hydrogen ions can be excreted in this way. So can potassium ions. It's necessary to excrete just the right amount of hydrogen ions because this is what maintains the homeostatic balance of the blood in terms of pH at between 7.35 and 7.45. Ammonia ions, the NH4 plus ion, can also be excreted into the tubules, as can some drugs. So what's basically happening is everything is filtered on grounds of molecular size. Large things like blood cells shouldn't be filtered. Large structures such as protein shouldn't be filtered, but smaller molecules are. Then as the glomerular filtrate passes through the tubules, that which is required is reabsorbed at homeostatic levels. That which is not required is simply left in the filtrate, and of course that will become urine, which is going to be excreted from the body. So we see these essential processes going on in all these million nephrons in the kidney. The process of the formation of glomerular filtrate, the glomerular filtrate being formed as a result of ultrafiltration, tubular reabsorption from the tubules back into the blood, and tubular secretion. Tubular secretion taking material from the blood and secreting that into the tubules.